Postgres 19 answers graph questions now. No extension, no plugin, no second database. It is in beta today, which is awkward because somebody is paying a graph vendor $28,000 a year for what Postgres just absorbed. So here's what landed, what it cannot do yet, and whether that bill goes away. The feature is SQL PGQ. It is part of the SQL standard, and Postgres 19 is the first release to implement it. The draft release notes already run past 200 entries, so plenty landed. But this is the one that deletes a line from a budget. Before this, a graph-shaped question in a relational database meant one of two miserable options. Write a recursive CTE and hope nobody has to read it, or stand up a second database and a pipeline to keep it fed. SQL PGQ is two things instead: a statement that describes your tables as a graph and a function that queries them like one. Create property. Graph takes tables you already have. Name the vertex tables, name the edge tables, say which columns join them. A users table becomes vertices. A follows table becomes edges with a source and a destination. That is the entire definition. Labels come along too. A table can carry more than one, so customers is both a customer and a person. Then graph table queries it with a pattern. Round brackets are nodes, square brackets are edges, arrows carry direction. Match a customer, an edge that says has placed, and an order. Choose the columns you want out the other side. Predicates go inside the pattern too. Filter that order down to today in the shape before anything gets joined. And it is a select, so it joins your ordinary, tables, filters, aggregates, and nests in a CTE like anything else. And nothing got copied. No import, no sync job, no second version of your data drifting quietly out of date. This is not an extension you install. It is built into the database itself by the people who maintain it. Here is the part that decides everything else. The graph is only a description of your tables. Think view, not new database. There is no graph store under it. The rewriter takes your pattern and turns it into ordinary relational joins. A traversal of depth n becomes n joins. That is the whole trick, and it is a good one, which means your existing indexes just work. Postgres plans it exactly the way it plans every other query you run. Run, explain over a graph query, and you get what you would expect. Nested loops, index scans, filters, nothing exotic. So performance is not a mystery box. If the join is fast, the traversal is fast. Forget an index and you feel it as usual. And because it is just joins, everything else still applies. Transactions, permissions, backups, connection pooling. The graph is not a special case anywhere in your stack. One database to run. That one design decision is why this is fast, why it is cheap, and why the next part is a real limit. Hey, don't forget to like and subscribe for more like this. Now, back to the video, because Postgres 19 only does fixed depth patterns. 2 hops written down gets you 2 hops. The quantifiers are not in this release. Star plus curly brace ranges. Ask for 1 to 5 hops and it will not run. So shortest path, transitive closure, every route between 2 nodes. Still a recursive CTE like before. Quantified patterns are planned for a follow-up patch. Worth knowing, but they are not in Postgres 19. And unbounded traversal is the exact workload dedicated graph databases were built for. Neo4j stores a direct pointer from every node to its edges, cost tracks the answer, not the graph. A relational join goes back to an index on every hop. Deep on a big graph, that gap gets enormous. There is a mature Cypher ecosystem too, browsers, drivers, visualizers, and people who already know it. Then there is the algorithm library, PageRank, community detection, node embeddings. Postgres has none, though even there, the graph gets copied into memory in a special format first. Not straight off the stored rows, so if the graph is the product, deep traversal, recommendations, fraud rings, keep the graph database. But most teams are not building that. They have a graph-shaped corner of an otherwise relational product. Neo4j's managed professional tier list at $65 per gigabyte per month. The high availability tier is $146. So a 16 gigabyte cluster on that tier is $2,336 a month. Call it $28,000 a year before anybody writes a query. To be fair, there is a free tier and you can pause an idle instance. Neither helps a graph that has to stay up, plus the pipeline keeping it in sync, plus somebody who knows Cypher, plus a second thing to be paged about. Against that, one statement in a database you already pay for, backup, monitor, and can operate at 3 a.m. And the graph query joins your ordinary tables in the same statement. No application code stitching two results together. The catch is timing. This is beta. Beta 1 landed June 4th, beta 2 on July 16th. And beta 2 carried several fixes to this exact feature, which tells you where it is. The project is aiming for September or October and says behavior can still change before then, which means do not put this under production traffic yet. That is the project's own advice. Testing it is easy though. Beta 1 is already in Amazon's RDS preview environment, so go and price it. Take your real graph queries and count how many are 3 hops or fewer. If they all are, that renewal just turned into a conversation. If they are not, you now know exactly which query is paying the bill.